top of the thing was, what, 4 inches across? So it's 4 inches across this way, and we also know it's 4 inches down this way, correct?
Wait, I have a question.
Yes, ma'am. Well, okay, yes. So let's revisit that then. Okay, it says here that the diameter is 2 inches at this point. That's 2 inches. Why does that imply halfway down? I'm asking you, because it's supposed to be your mathematical sense we're relying on.
I mean, I get why, like, I get that that's half, but I just didn't think that would, like, guarantee that.
It's a similar triangle, right? So this is to this, the whole thing, as this is to that, right? They're all similar triangle argument. Now again, I don't expect you to remember that similar triangle. I expect you to just kind of think like, well, that must be true. Is that okay? That means the radius up here was 2, but more importantly, the radius here has to be 1. Agreed? Well, we felt very confident. The height was 2. Height was 2 inches. And we were extraordinarily confident that we could find the HDT. We realized what formula we needed, so we used volume formula, which is 1/3 pi r squared h. In agreement?
Wait, back up, please.
Stop it.
The middle line, how do you determine that? The middle range.
It's 2. I don't know. There's dashes hanging off of it. It's 2 in diameter, which makes it 1 in radius. Is that okay?
Yes.
All right. So now look at this thing and go, all right, what are we going to do here? We're going to go ahead and use our formula. We know how to use our formula. Everything's good. We felt very confident. We did dt. And we said 1/3 pi 2r dr dt 8 plus 1/3 pi r squared dh dt. Are we in agreement? And then we started plugging numbers in, thinking we've got this cold. -1/2 equals 1/3 pi 2. R is 1 at the point I care about. dr dt, and that's when we went, oh dear Lord. Bad things happened to me. I don't know what rate the radius is changing at. How could I? So I'm stuck. Which means, whenever I'm stuck, that means what, Miss Noble? I have the wrong equation, which means this equation is wrong. But we were assured by Mr. Bellotti that that's the right equation, so we've got to be close. Now, what do I have to get out of my equation? What can't be in my equation now that I know it can't be in my equation? Radius. Is there any way to write radius in terms of whatever variables I have there? Well, I have h. How are h and r related to each other? The height is twice the radius. Now, you did that really, really fast. 2r equals h. I'm going to pause there and make sure everybody else in the room has a chance at that. Mr. Ballison.
Yes.
Is that okay with you?
So, how do we get rid of the 1/3 pi then?
We're not going to talk about that just yet. Are you in agreement? We need to get rid of r.
Yeah.
The 1/3 pi doesn't bother me. That was okay. I went 1/3 and pi was good there. I can't have an r in it because I can't have a dr dt.
Okay.
And so I'm now going to look and say, well, r can be written in terms of h, can it? Because after all, r is just half of h. When the radius was 2, when my height was 4, my radius is 1, when my height was 2, and I came up with that on my own because I realized it's a ratio.
Okay.
So it's always going to be half. Agreed?
Yeah.
Okay. Now, again, our strategy is we're trying to get rid of h. Sorry, we're trying to get rid of r. Why? Because r bothers us. It's dr dt. We don't have that. So I'm going to rewrite my equation so it gets rid of the thing I don't want. Now I'm pausing there because about half of you are nodding your head like you got it. The other half looks scared as rabbits and caught in the trap. Ready?
Yeah.
You're a rabbit. You okay? All right. You're waiting for the next step with anticipation. Disaster. Fair enough. All right, Miss Noble, change my equation so now it's one I can do.
V equals 1/3 pi
Okay, so we're going to replace the r with the h over 2. h's are okay because I need dh dt. Now I'm going to do a little bit of math that sometimes stumbles people, which is this is h squared over 4, correct? Times h. So I can multiply it in any order. I can make this v equals 1/12 pi h to the third. Remember, I move the 4 times the 3, got making myself 1/12. I got h squared times h, I got h to the third. Talk to me. Is it here the problem or is it here the problem? There, okay. So I squared h top and bottom, right? H squared and 4. And then to get to the final answer, I got 1/3, I got 4, so I just multiply straight across. 4 times 3 is 12. Still got my pi. And I got h squared times h, which is h to the third. Collecting my term for multiplication. You do it anywhere I want to, it's all multiplication, right? Should I lift it up?
No.
Okay, yes, sir.
So is h the reason we have h over 2? Is that because of the triangle?
Right. As I stopped the class and said, does everybody understand this? I said, she did that really fast. She noted immediately that 2r is equal to h. In other words, r is always half of h. So h over 2 is equal to r. And since I know that, I can replace r with h over 2. And that's what I did. Because I didn't want an r in my equation anymore, but I do want h's. All right, bring us home. It's double.
Okay, wait, can I do the product anymore if there's something?
Don't need a product rule, right? That's just a number sitting out front.
Wait, say it again.
We don't need a product rule, that's just a number. Like 4. Right?
So, so 1/4
Okay, so you jump. I'm going to go ahead and write it as 3 over 12 because you're going a little fast. That's okay. 3 over 5.
h to the second.
H to the second.
h.
What happened over here?
And that's
All right. dv dt is negative 1/2. That's equal to 1/4. That's a pi. H squared. H at the point we care about is 2, so that's going to be 2 squared. dh dt is what I'm looking for, and look, I can solve the problem. So, if you end up with the wrong equation, there's 2 possibilities. One, you're completely in the wrong place. Like you're picking an equation that can't possibly help you out. Or 2, if you feel really close, see if you can get rid of the variable that's bugging. And again, there's no rule for this. It's natural sense. You looked at the cone, you figured it's half. Okay, I can do that to get rid of my r and h. That's going to be hard to do every time. Yes? Yes, I put in 2 because that's how I had waters. The point I'm asking about is the height was 2. Now it's like, okay?
Yeah, I think so.
Okay. I'm going to cancel this out. I'm going to notice a really strange thing. 1 over 2 pi is equal to dh dt. What's my units? Inches per second. So water drained out of the bottom of that cone-shaped thing at negative 1 over 2 pi inches per second. Well, I got a 1/4 here. 2 squared is 4, right? So I canceled those out because 4 divided by 4 is 1. Then I dropped the pi over there and I'm done. Okay, we are at the high water mark, so we got to play with these a little bit more so we start to feel a little better about them. Which way do I go? So let's do this one. All right.
Thank you.
Okay, now we're going to start feeling better. This is the moment where we should be tense, justifiably so. Then after
I'm
this
so
moment,
scared.
you're scared. You should be. Very afraid. Really like you're unpacked. Hope this stuff is easy. Look how bad this stuff is.
Yeah, for real.
Take this. He's a jerk. I could be taking art right now. It's worth the same units. All right, everybody try number 1, please. I warn you in advance, don't overthink it. All right, fine.
Yeah, that's it.
Have at it. Overthink it.
Riley, you need to follow your steps. What's a differentiate?
Differentiable functions. Assume that x and y are both differentiable functions. In other words, you're allowed to take derivative.
What's differential?
You're taking derivative. Oh, wait, I know you're laughing. Differentials. A bad word. You mean derivatives? Rival.
Yeah, what's the story behind that? Like differentiate? That makes no sense.
No, differentiate sounds like the wrong phrasement.
Yeah. Yeah.
Oh, I should stop my movie. Movie stopping. Bye.